Hello, and welcome to the BME Horizon Hot Topics webinar, a weekly webinar brought to you by the Center for University-Industry Cooperation of the Budapest University of Technology and Economics. Let me give you a brief introduction about the university. At the university's 8 faculties, there are more than 1,200 lecturers teaching more than 10,000 courses each semester in the disciplines of technology, informatics, natural sciences, economics, business and management. The university is an active member of the European Engineering, Learning, Innovation and Science Alliance, LISA, the European University Association, and the Caesar Association of Universities of Science and Technology. As a research university, our primary task is the provision of high-level training to professionals capable of solving creative and innovative research and development problems and elaborating and implementing new products. Our researchers participate in high-level national and European research programs regularly. The Budapest University of Technology and Economics has ranked second among the Hungarian participants in the Age 2020 framework programs with 67 funded projects. I am Borbála Schenk, the Chief European Research Funding Advisor of the Budapest University of Technology and Economics, and my professional focus is providing support for our researchers in their successful participation in the Horizon Europe Framework Program. The European research area is changing dynamically nowadays. We organize this webinar, the Horizon Hot Topics webinar, to help our researchers and the research managers to get acquainted with the new trends and concepts that define the European research ecosystem. With the growing importance of achieving impact beyond the academia, the growing importance of open science, responsible research and innovation, we are required and also challenged to adopt new ways of thinking about research. These new ways are stimulated and incentivized by the European Commission as a prominent funder of research, and these requirements are also reflected in the Horizon Europe Framework Program. With these weekly webinar sessions, we would like to spark discussions, show you good practices and novel perspectives, interesting approaches, and want to help you to tackle these requirements with confidence. And our ambition goes even beyond that. We would like you to see the values, find the benefits of these concepts like stakeholder engagement and open science, and find out yourselves how these can lead to new and exciting avenues of high quality research. Our session today is going to last till 1:45 p.m. I am going to give a brief introduction of today's topic, then I am going to give the floor to our guest speaker. Our guest speaker is going to hold a 15-20 minute presentation, then we will open the floor for questions. Please add your questions on the Slido platform. The Slido is embedded on the web page, and if you are following us on YouTube, you can find the Slido link there. The platform for questions is already open. Please share with us your questions, your comments, and just join in the discussion. Today's topic is ethics and artificial intelligence. As artificial intelligence systems have spread into society, we have seen many problems arise due to the unethical aspect of these systems, such as, for example, racial discrimination. Like many other governments, the EU is taking steps to address these problems, both in science and law. These steps are founded on a set of commandments developed in the EU and to which artificial intelligence systems must comply to be trustworthy and ethical. The presentation today will summarize these commandments and how they are being embedded into both legislations and system design. Our guest today is Brandt Dainow, Dr. Brandt Dainow, Associate Professor of the Department of Philosophy of Maynooth University, Ireland. Brandt was a postdoctoral researcher on the Siena project, which finished in March 2021. In the Siena project, he developed frameworks for ethical artificial intelligence, including research ethics. These have now been adopted by the EU as official ethical requirements for all Horizon, Pathfinder, and similar AI research projects. He is a registered expert with the EU, where he undertakes ethical review of Horizon Europe and Pathfinder AI research projects and trains EU staff in ethical assessment of AI. Brandt, I am now going to give the floor to you.
Thank you very much.
I'm going to mute myself. Please share your slides and start your presentation.
Thank you. Hello, everybody. So, as I said, as the introduction said, we're going to talk about artificial intelligence ethics, particularly with reference to the European Union, the concerns the European Union has, and the ways that it is now starting to address the whole issue of ethical and trustworthy artificial intelligence. Realistically, at this stage, what we are talking about is the commencement of a 5 to 7 year process within the European Union. So at this stage, what has been formally implemented is things like research ethics and guidelines. A lot of this will follow through into legislation, which will start to appear in the next year or two. There are at least 2 major pieces of legislation going through. So while what I'm going to talk about is primarily focused on the initial concerns and the initial responses that the EU has brought into place, and obviously with respect to the focus of this series, its relevance for funding, please understand that what we're talking about is not specific to research projects itself. These are the first steps in a general approach to artificial intelligence deployment within society itself. The fundamental understanding that we need to come to is based on a systems approach. We understand technology as something that is a socio-technical system. That is to say, there are engineering requirements and engineering specifications, but there are also social practices, human understandings, cultural perspectives, and so on, which are at play here. One of the problems that we've identified through our research over the past, and this is particularly the case for end users of artificial intelligence and people who make decisions about how it's to be used, but also into the development community, is this idea that because an artificial intelligence system is embedded in machinery, in computer technology, it is somehow objective and more trustworthy than an individual human judgment may be. And as I'm sure many of you are aware, this is false. You cannot really separate the human approach and the social practices, and particularly the values and understanding of what is going on from the technical and operational features of an artificial intelligence. So we understand it as a system. That is to say, it is best understood as a series of processes. There is a feedback cycle in terms of the way artificial intelligence technologies impact on society, and then the way that the social response changes the development of the technology. As I'm sure most people know who do any sort of programming, there are normally multiple ways in which a particular solution or a particular function can be implemented within the technology. The choice of which ones to use is as much a cultural or a human choice as it is an engineering decision. So what we understand is that this creates what we call an autopoietic system. This is a system that is self-organizing. We see these cycles of activity and response, and then the impact that that has on the technological development as self-organizing and modifying. And what we are now experiencing and will experience over the next 3 to 5 years is really a response to the way the technology has been developed and used over the last 10 to 15 years. In addition to which, one of the things that we see that is confounding the place of artificial intelligence within society is the difference in perception of what it is that's going on between those who use the system versus those who design it. And often there is a competition in terms of how that proceeds, which can lead to systems being used in ways that the designers never anticipated. And I guess the classic there is email. Email was originally created so that server operators could get the protocols working between multiple systems together. It was never anticipated that it would be used for personal communication when it was invented, and certainly we never anticipated that at the end 80% of the email sent would be junk. So this is my simplified diagram for the AI socio-technical system. We have data, which is processed through machine learning techniques. These will continue to evolve. This leads to activities, actions on the part of artificial intelligence aimed at achieving goals. That itself has a social impact, and that the response of society is to create laws, regulations regarding how these things are to be used, which for the most part at this stage constitute a restriction in what you are allowed to do with artificial intelligence. The key problem that we've seen in the past with ethical problems with artificial intelligence have primarily laid in the data itself. So what we've discovered is the issue of who generates the data sets that are used for the artificial intelligence and what they choose to put in there, how they annotate it and so on, is having a huge impact on the ethical status and therefore the allowability of those AI systems. What our research has shown is that bias is not to be treated as an error in AI systems. Bias is endemic. It's like noise in a signal. It's unavoidable. There is no such thing as unbiased data. Bias occurs in terms of who selects the data that's used. It's in terms of what data is selected, why it's selected. We know that machine learning processes can introduce bias. We know that human intervention in machine learning processes, optimization strategies and so on, can also introduce bias. We know that bias can occur as the machine learning occurs, almost organically. We know that bias can occur in terms of the goals that people set out to put the AI systems to, and in terms of the activities. So what we're looking for is what I think is really a shift in terms of how engineers and computer scientists approach the development of artificial intelligence, in that they really need to understand that bias is something that is there unless it is proven not to be, not that bias is somehow an occasional error that occurs sometimes. So the EU's history in looking into the ethical impact of this technology actually goes back probably to 2005. For our purposes, the focus on artificial intelligence really commences with the high-level expert group on artificial intelligence. Their brief was to define what would constitute trustworthy artificial intelligence. So this incorporates, as a large portion of it, ethical concerns, but there are also things like reliability, access, and so on. The findings of the high-level expert group were then fed into the Sienna project, which I was involved with. Now, the Sienna project also looked at things like genetic engineering and so on, but the section that I was involved with was focused on artificial intelligence. So there was a lot of research over a 5-year period into what were the concerns, what were the problems, who was doing what, and so on. The net result was that we developed a set of guidelines. These start with values, what we understand as the core human values that all artificial intelligence systems need to respect. Values in ethical systems, values in society become instantiated, become activated through norms. Norms are rules of acceptable behavior. In terms of artificial intelligence, these are rules that it must obey. Where we like to think we were innovative was we then translated those into concrete technical requirements that systems must comply with, or development methodologies that developers must comply with. So we took a set of 6 core values, which I'll explain in a minute. We then determined the norms, of which there are, I think, 20 or 30 of those rules that an artificial intelligence should obey. And then we translated those into 64 specific tasks that must be undertaken during the development and operation of an artificial intelligence system. So our aim is to create what we call ethics by design. This is part of the values by design movement. You've probably heard of privacy by design and so on. The idea being that in the past, what we have done is we have created systems and then detected the problems and then tried to fix the problems, remediate back. What we're trying to move to is a situation in which the problems are anticipated from the earliest stages of design, and the system is then built in a way that makes those problems impossible, or at least difficult to achieve. So we're trying to be proactive in this respect. So the values we selected are as much as possible as uncontroversial as possible. We drew values from the UN Charter of Human Rights, EU legislation, constitutions, and so on. And in terms of name only, they're pretty much universal, such as things like all human beings should have personal freedom. Now, the Chinese Communist Party has implemented a set of values that they believe that artificial intelligence should comply with. And in fact, this opens up a general point. What the EU has done is not unique. We see the same things going on in China, in Australia, in the United States, in Singapore, in South Africa, and so on. Everybody is moving in this direction that we must apply values and rules to the way AI is developed and operated. And in general, the values are the same across the planet. What the Chinese Communist Party means by personal freedom may not be what the European Union means by personal freedom, but both agree that AI should not restrict personal freedom. So if we have a value of freedom, then that should be respected. Then the rule, the norm for the artificial intelligence system should be something as simple as that artificial intelligence should not restrict human freedoms. How you do that and how you make sure that that is the case, it's where we drop down into requirements. And what we're trying to do with requirements is treat them and get developers and engineers to treat them exactly the same way as they would treat any other type of requirement that's been pre-existing, like security, reliability, getting the bugs out, things like this. It's not treated as a special class of additional layer of requirements that's imposed on artificial intelligence. So the values, a respect for human agency. So this is stuff like autonomy, dignity, freedom. Data governance is really an implementation of GDPR. So we have privacy, but we're also adding to that. Obviously, it should be accurate. That's just basic functionality in any piece of engineering, but also that the data is manageable by humans. And this is one of the biggest shifts you're going to see in artificial intelligence requirements, is a role for and a requirement for humans in places that traditionally have been ignored or even considered impossible. Fairness is a straightforward, obvious one in any pluralistic democracy, so no discrimination, equal access, and so on. Well-being, again, straightforward. Artificial intelligence should not harm humans, people, societies, etc. This is one of the big shifts, transparency. We require that all AI systems are understandable in detail. by humans. We need to be able to understand what data has been gathered, why it's being gathered, how it's been formatted and annotated, what the code is that was used to drive the machine learning, how it was constructed. So not just what was constructed, but how. I'll talk about this, but basically this is things like if you select a set of data to be used for machine learning, you need to be able to justify why you used that set of data. So we're talking about understanding and being transparent within the development process itself. And then obviously we need to understand what it is that this thing is doing when we let it loose into the world. So these really lead down to what we're calling accountability and oversight. Some human is always accountable for the action of the artificial intelligence system. There is a movement in some branches of AI ethics to say these are self-referencing systems, they make their own decisions, so no human can be held responsible for them. That's not going to be acceptable anymore. Someone is always responsible. So at the development level, a developer needs to be able to explain how and why the system exhibits its characteristics. When it's being used, somebody needs to take responsibility and be able to report at any moment exactly what it is doing and why it is doing it that way. Now, the traditional response to accountability and transparency is to say, well, you know, it's a black box. We don't know what's going on inside. If certain new methodologies are used, or we have intellectual property values that mean we can't expose the code, none of that will wash. There's a concept called black box testing, which is I don't have to look inside to be able to test it any more than I have to expose the interior operations of a car in order to test it on a test track. So there are plenty of formally defined mechanisms and more coming to enable us to test the internal activities of an AI without actually opening it up and looking inside. Okay. So how does that translate into concrete tasks? We've broken down the development process into six. There's sort of theoretical phases, like, you know, you have to do a high-level design where you work out what it is that this thing's going to do, and you work out what resources you need in order to put that in place, version control systems, things like this. At that level, each of the values that we have defined, which led to the norms, places a set of requirements which are effectively tasks that need to be done. So there are, as I've said, there are 64. I can't possibly go through them all now, but I just wanted to give you some samples so you have an understanding of how this works. At the initial design stage, the data governance requirement basically says, assume all your data is biased. So you need to design a formal process to detect and correct for that bias. You need to be able to justify the process, why you selected it, how you used it, and you need to demonstrate, provide and record evidence that you actually did that. One of the things that's coming, and we've already started to see this in legislation in some parts of the world, is the requirement for an artificial intelligence system to be suitable for external audit. This will become more and more of a feature. So when you're designing a project, you're as well as looking into how the data is going to be de-biased, if you like, you're also going to have to document that in a way that an external person can come in and evaluate and check. Transparency, another value that would have to be considered at this stage, is the designing systems and mechanisms which are human readable, by which the system records its own decisions and which can become made available for audit. Obviously, data collection is fundamental to artificial intelligence. We are also aware that some systems call on a limited number of pre-existing data sets, many of which have already been annotated. So, for example, the majority of voice recognition and voice processing artificial intelligence systems draw their initial data set from only 4 or 5 major systems such as DBNet that are used globally. We know that there is bias inside those systems, and we know that particular ways of processing them, machine learning, can add further bias to them. So those are the sorts of things that have to be assessed. And for example, if you were designing a research project that was going to use DBNet, the fact that the bias in it is well documented, published in peer-reviewed research and so on, means that there would be absolutely no excuse for not anticipating bias, understanding what that bias is, and in the case of DBNet, there are already a few established methodologies for countering that bias, and you would have to show that all of those processes have been well understood. The major problem with bias in data sets about humans is that it is effectively inaccurate. It's not representative. It draws on insufficient samples. In a lot of cases, the problem is that the data has been gathered through human activity, which was in itself biased in the first place. This is one of the endemic problems in predictive policing systems, judicial sentencing systems, and so on. They typically work by analyzing what the police have been doing and then extrapolating into the future. But in cases where the police have been biased themselves, what they have generated is biased data sets. There are other problems in it. So, for example, as we know, facial recognition systems are less accurate with women and with people with darker skins. And again, there would have to be a mechanism by which, if you take a pre-existing data set or if you're generating these data sets, you show a knowledge of and compensate for these sorts of problems. Similarly, during data collection, transparency is an issue, which is to say you would have to be transparent. You would have to show how you have looked for, identified, and remediated data bias. Particularly when it comes to personal data. I'm not a lawyer. I'm not going to talk to you about GDPR, but obviously GDPR is an issue. But there may be additional requirements in there as well. Again, you would have to demonstrate a knowledge of those. When the development process is going place, this is going to when you'll see the biggest changes in the development cycles, because historically people have not had to document what they've done during the development process to a level where an external person can come in and audit it. So you need to have formal processes to manage and secure the data. So, for example, we require that there are mechanisms to ensure that when people are bug testing, they don't get exposed, they don't have access to personal data beyond what is absolutely necessary for those purposes. Often when people are dealing with these sorts of things, the system itself may not deliver personally identifiable data at the end of it, but you can see it during the development process. There need to be formally documented mechanisms for recording who's got access and why and so on. There needs to be ongoing checks for bias in under the fairness requirements. Remember, we're working on the basis that at any stage through the development process, even if the data itself is completely unbiased, bias could be introduced by any number of different mechanisms along the way. So checking for bias on an ongoing basis is as far as we're concerned, on exactly the same level as checking for bugs. It's just something that goes on, and you understand that these can occur at any stage during the process. And within that, not only do you have to have mechanisms for recording this and making it available for external audit, you have to have systems that are generating that auditable material on the way, human readable format or on the way. So generally, I think you can call this transparency. The system needs to record what the models are, how it's trained, what data was used, the logic that went into those decisions, and so on. This is not something that's unique to European Union funding applications or research. This is what's known as explainable AI or XAI. It is a huge initiative. As I've said, this is a global movement. The EU is ahead of the curve in terms of where the rest of the world is at, which means, as we've seen with GDPR, it will be what the European Union does will be used as a model and copied. And in addition to which, commercial organizations such as Google and Microsoft and so on are very aware that this is a coming requirement. So we now have an entire field of development under the name XAI. You can go into GitHub and so on. You can see tools, methodologies, approaches, and so on, model cards, data sheets for data sets. These are mechanisms that can be inserted into an AI system that will programmatically generate the human readable material that we need. So I'm afraid the days where people have argued against us on the grounds that it's not technically feasible and so on are gone. It is very technically feasible. There is no doubt, however, that it imposes extra burdens on the development process. It may slow it down. It will certainly make it more resource intensive. You may require new people. You may require additional people sitting over the top of the engineering staff and so on, maintaining and monitoring these. It will require additional organizational features and so on. And I'm afraid the European Union doesn't see that as a problem. That's life. Testing, for example, one of the key things that we're looking at in testing is transparency. One of the major problems we've seen with the use of artificial intelligence is that the users do not understand what it is that they are dealing with. And in particular, they trust it too much. They don't understand its limitations. They often assume that because a machine did it, it must be objective, it's mathematically defined, it's perfect, and so on. So during the testing cycle, we would look for evidence that the limitations of the system have been communicated to the users. And then, as I said, oversight, as you've seen, goes all the way through this. So at the testing stage, we need to ensure that there are ongoing mechanisms for people to report problems with it, because we're assuming that most AI systems that are deployed will continue to learn and continue to change, and so can never be trusted without being monitored. So that's it in a nutshell. For purposes of research applications, it is very important to understand that research applications in front of the European Union now look for formal compliance with these ethical concerns. So it's no longer sufficient to design a system, say how you'll put it together and all the expertise and so on that's going on in there and make it a believable set of work packages and so on. We are now looking for evidence of compliance with these requirements. Now, we're at an awkward stage because having developed these requirements, they are in the process of going through translation into 27 different languages and all the other bits and pieces that go to formally releasing a set of guidelines. They have been released in English, but not at an official level yet, because they need legal checks and they need to be translated into 27 languages and so on. But you can go to the Siena Project report, you can download this document, it will explain the background, and it will go through in detail every single one of the requirements that are needed. So that's it in a nutshell. I'm going to recommend that you review this document if you are looking at doing any form of research applications and so on. But generally speaking, if you're looking at developing AI systems from now on, understand that this stuff is going to be, as appropriate, it's going to be instantiated in law. We're looking at the first laws on artificial intelligence going through the European Parliament either later this year or early next year. And a lot of that is based on this, and also carries through into what will become a licensing regime. So I expect that within 5 years, you won't be able to release an AI product into the marketplace until it's been formally evaluated and licensed, and these are the foundations that licensing and requirement regime will be based on. So that's it in a nutshell. Thank you very much. I will now open up to any questions.
Thank you very much, Brandt. That was a very comprehensive presentation. And both as a lawyer and the European funding advisor, it was very, very interesting for me. And as I see the questions also for the audience, let me just share my screen with the Slido board. And also I would like to show the briefly the Siena project. Okay, so what you just mentioned. Can I get a confirmation that my screen is shared? Okay, thank you very much. So yeah, this is the Siena project. This is the website, and you can find a lot of useful materials there, all the deliverables. Just to get back very briefly on the last sentiment of your presentation. So if our researchers want to apply for EU funding with research concepts that involve AI, they have to complete an ethics self-assessment that also involves AI issues. How and where can they find guidance for how to do that? Can we just summarize it again?
Yeah, sure. At this stage, you really need to go into the document that I referred to. One of the problems with the application form for the for these research projects is the ethics section at this moment is primarily focused on things like GDPR and so on. So there's a little box at the bottom that says any other issues. And really at this stage, that's where you have to address this whole topic. So this is, I guess, if we came back in 6 months, we'd have much more formal documents that we could look at on the EU website and so on in appropriate languages. There's talk of modifying the form on the EU, but as I'm sure you know, the EU is a gigantic bureaucracy. So something as simple as putting in another section is highly controversial. We did actually design one which has all of the different tasks, and you tick whether you're doing it and how, or whether it's not applicable and why, and so on. The general response was that this added 30 pages to the application form. It was intimidating, it was confusing. We couldn't possibly expect poor engineers to read as many as 30 pages. That was unreasonable. So it may turn up as a voluntary aid, but it's highly unlikely to end up on the form. So I'm afraid it's really, this box at the bottom that just goes, anything else you want to say about ethics?
Yeah, and what is actually at stake? So when like writing this ethics self-assessment, so can the proposal be rejected because yes. of
yeah, but it would have to be, really, it would only be rejected automatically if it directly violated one of these core values. So, for example, if you built an AI system whose job was to specifically reduce human freedom, then they're just going to cut it straight away. For the most part, what I'm seeing is the feedback goes back that, you need to do more on an ethical nature. If it's minor stuff, then these will come back as additional requirements in the project. If they believe to be difficult or serious, then it will go from an initial assessment to a 3-panel ethical review, people like myself and so on, who may produce more detailed requirements. In some cases, this is nothing more than a sentence or two. On the last one I did, it was literally 22 pages we went back with, and we went through every proposed work package and said, you've got to do this, you can't use that database, you've got to compensate for this, we want to see this appointment panel, we don't like the composition of the ethical review board, we don't think there's anybody with suitable expertise there. we want to see it covering the ethical review board during the project, reporting every 4 months, and these are the issues that are to be reported. So in some cases, we're going back with really detailed ethical requirements that then need to be rebuilt into the application and resubmitted and so on. So it depends on the type of project. We need to remember that a lot of AI has got nothing to do with humans. It's got no real ethical issues. If you're building an electrical management system, it's not going to crop up. And a lot of the applications we see, we just go, yep, it's literally no relevant issues. In other cases, I mean, I looked at one where the idea was to build a robot who was going to go out into the environment, randomly generate new chemicals, put them into the environment and see what happened. They called it automated robotic research. That one was just killed stone dead. I mean, the potential environmental impact was just horrific. And they just basically went, no. However, we noticed that part of this application is the ability of a system to generate new chemicals, and that in and of itself we wouldn't have any problem with. It's when you want to stick it in a robot and let it loose in the environment that we have a problem. So maybe you want to come back with a modified application. It's too modified to be considered the same application, but we wouldn't have any problems with these issues. So it depends on the severity and the way in which it's been handled. We're particularly concerned about a lack of awareness of social impact. So there was a system we were looking at which would predict. It was predictive policing, and it would predict and track and report and literally change border access for people that the AI system had considered to be suspicious, with no definition of what constituted suspicious. That sort of thing and what they looked at there in social impact was, they said everybody will love it, nobody will worry. And that was literally the sum total of the social impact assessment. So the whole project was sent back. It would have been sent back on other issues, but you can't just go, oh, everybody will love it, there's nothing there. You've got to, if you think everybody will love it, then show justification for it. What we're looking for is evidence that people have thought about these issues. What we're seeing and what we're putting a stop on, for the most part, is where people aren't taking them seriously or haven't really thought it through. And in particular, often the concern is that the perceived stakeholders are too narrow. So, for example, if I'm creating a predictive policing system, then the end users and the people who are going to be impacted are not just the police. So when you're doing your social impact statement, it's not sufficient to say, well, you know, the police service have got no problem with it. We want to see you've talked to lawyers, civil liberties organizations, if it's targeted at a particular group or a particular location, that you've spoken to those people as well. And so generally, I have to say, it's not so much that people have bad intentions or anything like that. It's generally a lack of thought outside the engineering elements itself in terms of how this fits into society, which is why I started the whole presentation by talking about we understand it as a social system in which the technology and the humans are interacting in such a way that you can't really separate one from the other.
Absolutely. Thank you very much. It seems to me that we have to have a new session on this topic in like half a year or maybe like 9-10 months, because well, there is a huge interest. I see the questions as well, and also it would be nice to see the practical piece of legislation and the experience you've had by that time. So I apologize for the to the audience, but we are not going to tackle the questions. Maybe we'll come back to that as later session, in a later session, because our session today for today is over, and I would like to show you very briefly the topic of the next session, which will be next Monday. Which is called Open Lab, Leading the Transition to Positive Energy Neighborhood with Living Lab Practices. We are going to listen to a project presentation. And I would like to thank Brandt for this very interesting presentation, and also for touching upon the societal aspect as well, and for including societal impact in the presentation as well, and for all the practical examples. So thank you very much, and we are going to continue this discussion at a later stage. Thank you.
Thank you. Thank you very much, folks. Take care.
Thank you, and see you next week. Bye.